Hi, AP Stats. We're going to do a two-sided test, and it'll probably go a little quicker because I'm not going to write all the answers. I already have them written out, but you can pause the video to write down everything you would need. So when the accounting firm, AJL and Associates, audits a company's financial records for fraud, they often use a test called Benford's Law. Benford's Law states that the distribution of first digits in many real-life sources of data is not uniform. In fact, when there is no fraud, about 30.1% of the numbers in financial records begin with the digit 1. However, if the proportion of digits that are 1 is significantly different from 30% in a random sample of records, AJL and Associates does a much more thorough investigation of the company. Suppose that a random sample of 300 expenses from a company's financial records results in only 68 expenses that begin with a digit 1. Should AJL and Associates do a more thorough investigation of this company? When I read through this, I notice a couple things. We are told that if there is no fraud, 30% of the numbers begin with a digit 1. So that's our assumed proportion. It is our null hypothesis. Then it says, if it's significantly different than that, notice that they are not giving us a direction. They are not saying larger or smaller, just if that proportion is different. P is not equal to 0.0301. Then we are given a sample, so our statistic is 68 out of 300. Let's go through our state plan, do and conclude. Of course, in our state, we want to test the following hypotheses at a alpha equals 0.05 significance level. They don't tell us a significance level, so 5% is great. That our null is that the true proportion is 0.301, and the alternate is that it's not that, where P is the true proportion of expenses from financial records that begin with a 1. Again, if you need to pause the video, I don't know if you can hear that, but there's an announcement going on right now. If you need to pause the video to write that in your notes, please do so. Otherwise, let's talk about the plan. In the plan, of course, we're going to tell which method we are using and check the conditions. So we will use a one sample z-test, assuming the following: random, normal, and independent. It is random because there was a random sample. It is normal because n times p and n times 1 minus p is greater than or equal to 10. And it is independent because it's reasonable to assume that there are more than 3,000 expenses for a company. Remember, for our normal condition, we are using p sub 0, the null hypothesis p, because we are working under the assumption that the null hypothesis is indeed true. Our next step is our do. In our do, we have to do two main things: calculate a test statistic and then a p-value. For our test statistic, and we'll start here. For our test statistic, it is a z critical value. Okay. Again, I don't know if you heard that, but there was an announcement, so oh my goodness. Back-to-back announcements. We were calculating a test statistic, which is a z-score. So our statistic minus parameter over the standard deviation of our statistic. Our statistic was that 68 out of 300. Our null hypothesis p was 30.1 or 0.301. And our standard deviation was the square root of p sub 0 times 1 minus p sub 0 all over that 300, our sample size. When I calculate this, I get a z-score of negative 2.81. Now the next piece is the one part of this problem that's a little different than we've done before. It's finding our p-value. Remember, a p-value is the probability that we get a statistic this big or bigger in the direction of our null hypothesis. Well, our null hypothesis here is that z is not equal to that p is not equal to 0.301. Which means if I want to find a probability here, I'm really going to be looking at two different things. If I draw my normal distribution with negative 2.81, I want to figure out what's the likelihood it is that big or bigger. So I'm looking at this area to the left of negative 2.81. However, it could also be that big in the other direction. So we do want to find both of these probabilities, either less than or equal to the probability that we get a z critical value less than or equal to negative 2.81, or the probability that we get a z critical value greater than or equal to positive 2.81. We want to look in both directions because that's what it means by this not equal to, as big as this statistic is or bigger. To do this, we can find one of those probabilities and multiply it by 2 because we know that a normal distribution is symmetric. So I went to normal CDF. I put my lower as a really small number, my upper as the negative 2.81, the mean and standard deviation of 0 and 1. I took that number, multiplied it by 2 for a p-value of 0.005. Once I have my p-value, we can write our conclusion, which would be as follows. Because our p-value is less than our significance level, we are going to reject our null hypothesis, which means we do have convincing evidence to suggest that the true proportion of expenses that begin with a 1 is something other than 30%, which means, yes, we should investigate this company for fraud. In class the other day, we talked about this idea that confidence intervals and significance tests are related, that a confidence interval would give us an interval of plausible null hypotheses that would not be rejected by a two-sided significance test. So let's see if that result would be true for this problem. We're going to look again at this expense example, but we are now going to calculate an interval. And I'm going to do it kind of quickly. I'm not going to do the full state plan do and conclude here. Find and interpret a confidence interval for the true proportion of expenses that begin with the digit 1 for the company in the previous example. So for A, we're really going back to chapter 8. Our confidence interval is a statistic plus or minus a critical value times the standard deviation of our statistic, square root of p hat times 1 minus p hat all over n, which means I am looking at the 68 out of 300 plus or minus, I'll come back to my critical value in a moment, and the square root of 68 out of 300 times 1 minus 68 out of 300 all over 300. Now, what significance level should we use here? Well, if in our last example we used an alpha is 0.05 for the significance level, we should use a confidence level of 95%. Which means what z value would we be using here? We might remember this. This is the 1.96 z critical value. When I evaluate this interval and do a little bit of algebra here, I get 0.18 to 0.27 as my interval. Now, what would this mean for the context of our problem? And actually, I will go back. It says find and interpret a confidence interval for the true proportion. What we would say is we are 95% confident. We are 95% confident that an interval from 18% to 27% captures the true proportion of expenses that begin with a 1. So if we think about this interval in the context of our problem, it says use our interval to determine whether this company should be investigated for fraud. What we said is if they were doing everything correct, if they were not doing any sort of fraud, the true proportion would be about 30%. If we look at our interval, 30% is completely outside of our interval. It is 100% above that. So for B, because 30.1% is not in our interval, this company should be investigated for fraud. because what we're saying is that their true value is something other than that 30%. That is our 9.2 notes. Oh, actually, there's one other tiny thing. So sorry. Question, how do I choose which inference method? Honestly, they're going to tell you. They are going to say, create an interval, run a test. However, if you were in the real world, if it is a one-sided alternate hypothesis, you're going to want to use a significance test. That's going to give you more information. If it is a two-sided alternate hypothesis, a confidence interval will end up giving you more information. If you think about it, for a two-sided hypothesis, we don't know if it's greater than or less than, but the confidence interval would give you that information. The confidence interval would give you values that are either above or below. So again, this is probably not something that you'll see on the AP exam, because on the AP exam, they will say, run a significance test, create a confidence interval. But here, it is kind of interesting if we're thinking of this as a statistician. Have a good rest of your day.